Hi, welcome back to General Mathematics class. We are still on our lesson on operations of functions. This is review lesson number 2, which is multiplication of polynomials. Unlike addition and subtraction of polynomials, where only like terms undergo these operations, multiplying unlike terms is actually possible. Let's take this for example. Multiplying polynomial by a monomial. To operate this one, we multiply each term of the polynomial by a monomial. Taking this example, 3x times the quantity 2x squared plus 4x minus 5. Again, to do this operation, we must multiply each term of the polynomial by the monomial. So we will have 3x distributed to our trinomial 2x squared plus 4x minus 5, resulting to 3x times 2x squared plus 3x times 4x plus 3x minus 5. Simplifying, we will have 6x cubed plus 12x squared plus negative 15x. To simplify this further, we need to eliminate the grouping symbol, resulting to our final answer, 6x cubed plus 12x minus 15x. Let us now proceed to multiplying two binomials. With our example, x squared minus 3 times the quantity x plus 2. To find the product of two binomials, the most common method is the FOIL. FOIL is a mnemonic that helps in converting a product of two binomials into a sum of 4. F stands for first, where the first two terms of the binomials are multiplied. From our example, that's x squared times x. O stands for outer or outside, where the outer terms are multiplied. That is, the first term of the first binomial and the second term of the second binomial, giving us the next term plus x squared times 2. I stands for inner or inside, where the inner terms are multiplied. That is the second term of the first binomial and the first term of the second binomial, giving us the term plus negative 3 times x. And L obviously stands for last, where the last terms of each binomial are multiplied, giving us the term plus negative 3 times 2. The resulting expression is now x squared times x plus x squared times 2 plus negative 3 times x plus negative 3 times 2. Simplifying this, we will have x cubed plus 2x squared plus negative of 3x plus negative of 6. Simplifying this further by eliminating our grouping symbols, we have x cubed plus 2x squared minus 3x minus 6. Since there are no like terms in this resulting expression, this is the simplest form of our product. There are many other patterns to recall in multiplying polynomials. Some will result to special products. Examples of these special products are the following. The square of a binomial, wherein if a binomial is multiplied by itself, the resulting trinomial is patterned wherein the first term is the square of the first term of the binomial, the second term is twice the product of the terms of the binomial, and the third term is the square of the second term of the binomial. This pattern is also followed if the operation between the two terms of the binomial is subtraction. Another special product is the cube of a binomial, wherein the binomial is multiplied by itself 3 times. The pattern of the product is that it should be a polynomial with 4 terms, wherein the first term is the cube of the first term of the binomial, and the last term of the product is the cube of the last term of the binomial. The second term is 3 times the product of the square of the first term of the binomial and the second term of the binomial. And the third term is 3 times the product of the first term of the binomial and the square of the second term of the binomial. This pattern is also followed if the operation between the terms of the binomial is subtraction. The next special product is the product of sum and difference of the same terms, with the pattern x plus y times the quantity x minus y that will result to x squared minus y squared. And the last special product is the square of a trinomial, with the pattern quantity of x plus y plus z squared, resulting to the first 3 terms as the square of the 3 terms of the trinomial, and the fourth term being twice the product of the first and second term of the trinomial, the fifth term as twice the product of the first term and third term of the trinomial, and the last term of the product is twice the product of the second term and the third term of the trinomial. This pattern is also followed if the operation between the terms in the trinomial are subtractions or a combination of addition and subtraction. That ends the review lesson on multiplication of polynomials. I hope you're now ready for the lesson operations on functions.